This video is the first in our series on the periodic table and the properties of atoms that can be predicted based on their relative location on the periodic table. In this series, we will not only look at how the periodic table was initially developed, but also how the shape of it can be explained by our four principal quantum numbers. We will look at electron configurations and then finish with a look at the various properties of atoms, such as atomic size, ionization energy, that can be predicted based on our periodic table. By the end of this series of videos, you should be able to, given an element, write out the electron configuration, both long form and shorthand forms, as well as the orbital diagrams. Given an electron configuration, determine the element it belongs to, predict the trends in atomic size of anions, cations, and neutral atoms given a periodic table, predict the trends in ionization energy of anions, cations, and neutral atoms given a periodic table, predict the trends in electron affinity for neutral atoms given a periodic table, and determine if an element will be paramagnetic or diamagnetic. Some of the terms that are related to this chapter are the Pauli exclusion principle, electron configuration, orbital diagram, Hund's rule, the Aufbau principle, degenerate, metals, nonmetals, metalloids, noble gases, alkali metals, alkaline earth metals, halogens, the effect of nuclear charge, diamagnetic and paramagnetic, and ionization energies and electron affinities. So why is it that we're interested in being able to make predictions using the periodic table? Well, the atomic radius is an important factor in determining the strength of chemical bonds and bonding in general. In acid-base chemistry, which we will be looking at in the second semester of our general chemistry series, we can determine the strength of some acids based on the radii of the atoms in the molecule. In organic chemistry, the size of atoms affects the ease to which they can react with active sites on molecules. The ionization energy gives us a way of predicting the ions that we can expect to see from particular atoms. Electron configurations can tell us how strongly an atom will interact with a magnetic field. We can use this property for things like MRI machines, magnetic resonance imaging,